Here's some more on triangles. So if you have a triangle that, say, looks like this, so here's the right angle, and then here is your hypotenuse. See if I can draw this without messing it up. There we go. Then you should be able to find the sides given these angles. So let's say, let's choose a different color, green. So let's say we know this angle right here. So that's our angle theta. So this looks a little bit different. This is an angle measured to the vertical. And what I mean by that is that here's a vertical line, and here's your hypotenuse. If you looked at the previous example, the angle was measured relative to a horizontal line. But now your adjacent side is up and down in what we would call the y-axis. So that's up and down, and there's your hypotenuse. So to find this adjacent side, we'll use cosine, but look at the fact that it's in the y-axis. That tends to really bug people. But still, this is the adjacent side, that's the opposite side, and that's your hypotenuse. Again, you just have to recognize that the adjacent side is the side next to the angle along with the hypotenuse. The adjacent side is always in between, the angle is always in between the adjacent side and the hypotenuse, and the opposite side is always, of course, opposite there. Another type of triangle we're going to run into when we're studying forces on inclines is one that looks like this. You've got the hypotenuse pointed straight down. Let me try that one again. You've got the hypotenuse pointed straight down. It will eventually become an arrow, but we don't need to do that right yet. And then you've got a side down here, and then we complete our right triangle here, and here is the right angle. So this is the hypotenuse. We measure the angle, in this case right there, so there's theta. This is the adjacent side, and this is the opposite side. In all of these cases, we still follow good old SOHCAHTOA. It's just up to you to recognize what's the hypotenuse, what's the adjacent side, and what's the opposite side. Of course, the hypotenuse is always going to be opposite that right angle. Okay, a couple other points that I want to make. There are some triangles that we see a lot of in physics. This is particularly true in AP Physics, but all of you should be aware of this. Of course, you know a 45 degree angle, 45, 45, 45, 45, 90. So let's say that if that's 45 degrees, and that's 45 degrees, then this is 1, that's 1, and this is root 2. You know from the Pythagorean theorem that 1 squared plus 1 squared, so 1 squared plus 1 squared, and take the square root of that, that's where this comes from. All right, so 1 plus 1 is 2, and the square root of 2. All right, so that's one type that you should recognize, 45, 45, 90. Another one, let's choose that color. This is pretty common. This is one of my favorites. Here's your right angle. and this is 30 degrees, which makes that 60. And so for this one, this is 1, that's 2, and this would be the square root of 3. And then the last one I want to point out that we should know, let's go with purple, that's exciting. I didn't draw this to scale, oh well. This is 37 degrees, and this is 53 degrees. And for this is actually a 3, 4, 5 triangle. So you should know, the AP folks in particular should know that the sine of 37 is 3 over 5. The cosine of 37 is 4 over 5. The sine of 53 is 4 over 5, which of course is the same as the sine of 37. Sorry, cosine of 37. And then the cosine of 53 is 3 over 5. And then in terms of your tangents, for example, 3/4, that's tangent of 3/4. 37 degrees. Sorry, the tangent of 37 is 3/4. These are things that you should absolutely know. Also, along with this, you should know that the sine, you should all know the sine of 0 is 0. Sorry, that's supposed to be a 0. The sine of 0 degrees is 0. The sine of 90 is 1. You should all know that the cosine of 0 degrees is 1. The cosine of 90 is 0. You should all know that the sine of 180 degrees is -1. And lastly, you should know that the tangent of 45 degrees, which I should add you can get from this triangle, the tangent of 45 degrees is opposite over adjacent. The tangent of 45, lo and behold, is 1. So there are some special trigonometric values that you should know. Again, a 45, 45, 90 triangle, you should know these values so you can figure out the sine, cosine, and tangent without a calculator. All right? Sine would be 1 over root 2. Cosine would be 1 over root 2. And then tangent is 1 for that. You look over here. Sine of 30 degrees is 1/2. Cosine of 60 degrees is 1/2. Cosine of 30 degrees is root 3 over 2. And sine of 60 is root 3 over 2. And lastly, over here, this is one of the favorite angles for you AP folks. This is one of the favorite ones they like to use, these two right here. The sine of 37 degrees is 3 over 5. The cosine of 37 degrees is 4 over 5. The sine of 50 degrees is 4 over 5. And the cosine of 50 degrees is 3 over 4. And then you've got your tangents. Tangent of 37 is 3 over 4, etc. You should memorize these. AP folks, you should memorize these. You should absolutely memorize them. They give them to you on the AP test, but you do not want to spend your time looking them up on the AP test. You should know them.